Hello, welcome back. We're going to talk about the theoretical probability, which I mentioned in the last video, where that was based on theory. Okay, we did not have an experiment. It's actually based on the number of ways the event can occur. Doesn't mean it did occur. We didn't do an experiment, but it could occur that many. Over the number of ways, the number of equally likely outcomes. Okay, so what's super fun with this is that if you have two events that are complementary, that's an important word, that, wow, why did I write when? Then their probabilities equal 1. So let's pick two complete opposites. The probability of it snowing plus the probability of it not snowing would equal 1. Let's say on Easter, which it's supposed to have snowed. Now you'll be watching this after Easter, but I saw that we're supposed to get snow. Let's say the probability of getting snow was 0.6% or 60%. Then the probability of not getting snow would be 0.4 or 40%. And when you add those together, you get the 1. Or if you did it in percentage terms, you would get the 100%. Okay? So let's have some fun with this now. This is where I think it gets fun. An experiment consists of rolling a number cube. So one number cube. Find the theoretical probability of each outcome. That means we're not actually rolling it. We're just saying what, if we were to do this, what are the chances that this would happen? So first of all, remember in the fraction, just like before, the bottom number is always your total. So in the number cube, there's a chance of 1, 2, 3, 4, 5, or 6 when you roll it. So there was 1, 2, 3, 4, 5, 6. 6 possibilities in the bottom. How many of those are the number 5? 1. So my chances are 1/6. And if you actually took 1 divided by 6, you would get 16 2/3%. Okay, next one says probability of rolling an odd. Okay, it's still the one number cube. The bottom number is still 6. I didn't change that. It's still, these are all your possibilities. But what is changing is the top. It says rolling an odd number. So we need to look in here and say how many of these are odd. 1, 2, and 3. So there is a 3 out of 6 chance, which you can see reduces to 1/2, which is 50% chance. Okay, rolling a number less than 3. Okay, the bottom is still a 6, and if it's less than 3, so you need to look at the numbers that are here, and how many of those are less than 3. This one is, and this one is. So we have 2, which reduces to 1/3, which is 33 1/3%, or 33.3 repeating, or 16.6 repeating. All right, so that's one type when we talk about cubes and stuff. Another one we're going to think about is, well, actually, halt. We're going to get to the marbles, I think, in a little bit. Let's see if we're doing marbles. Oh, I guess not. Maybe today. That must be coming up in the future. Example 2, a box contains only red, black, and white blocks. The probability of choosing the red block is 1/4. The probability of choosing the black block is 1/2. What's the probability of choosing the white? Well, using our concept of complementary probability being always equal to 1, I know that if there's only 3 types of blocks in there and they gave me the probabilities of 2 of them, I know that altogether they need to equal 1. Okay, so I'm going to take the 1/4 plus the 1/2 plus whatever the white is, right? Because this was my red, And this is one my black, and this is all I have in there. So when I add these three up, it better equal that 1. Now some of you can probably do that in your head. A fourth plus a half is 3/4. And then what's missing here would be 1/4. Let's say you were having some trouble with that. You'd get a common denominator here, which would be 4. You would multiply this by 2, and you would get 2/4 plus 1/4 is 3/4 plus 1/4 equals 1. Or subtract the 3/4 from both sides if you still don't see it. All right. Now, the probability, example 3, the probability of rolling on a 2 on a number cube is 1/6. What are the odds of rolling a 2? Okay, so now, class, we're getting into a whole nother concept, and your eyes need to be aware that this is probability, 1/6. But they didn't ask you that. They said odds. Okay, we haven't talked about odds yet. You'll hear a lot about odds with, horse racing is one thing that comes to my mind right away, but you'll see it in lots of different things. So when we're doing odds, we're looking at, it says, what are the odds of rolling a 2? Okay, so odds are written, first of all, with a colon. And second of all, the two numbers you put in here will always equal this bottom number together when you add them. Okay, it's basically kind of splitting it. It says, what are the odds of rolling a 2? Okay, rolling a 2 goes here. And then the flip of it goes here. The odds of not rolling a 2. Okay, so the probability of rolling a 2 was 1 out of the 6. So this number 1 represented the probability of rolling a 2. Okay, so that is what goes in here. That's my 1. That 1 on the top represented rolling a 2. So how many go over here? What are the chances? There were 6 total. 1 was that I was rolling a 2. How many are that I'm not rolling a 2? Correct, 5. So 1 to 5 is how you can say that. The odds are 1 to 5. Okay, let's try another one. The odds in favor of winning a contest are 1 to 9. So whatever they mentioned first. So now look at, they gave us the odds this time. This one represents being in favor of winning it. Or winning it, we could just say. These are odds of losing. Okay, they're always the opposite of each other. What is the probability of winning the contest? Well, the winning number goes on top, 1. How do we figure out what goes in the bottom? What was that connection we saw here between this? It's always the total. See, this is broken down. Win, lose. But in a probability, the totals on the bottom, they add them. So 9 plus 1 is 10. And we are done with that one. All right, and lastly, the odds against a spinner landing on red are 2 to 3. Okay, so the odds are against. So that means it's not going to be red. It's against landing on red. So if there's 2 chances that it's not going to be red, and 3 chances that it is going to be red. The complete opposite. So what's the probability of the spinner landing on red? Well, this is a little trickier because, see, it's not always the first one. Up here it was the 1. That's why you really need to understand what those represent. In this case, the 3 is what's representing the red, isn't it? So the 3 is going to go on the top. But my total on the bottom is figured out the same. You add them together, and we're done. So that's the lesson for 10-6. I don't think there's any more. But what I do want you to understand is if you're having trouble with this, guess what, you guys? You can listen to this all again with the odds and the probability. Okay? All right. Well, take care. We'll see you in 10-7. Bye-bye.